The Juno probe, launched by NASA 6 years ago, has been gathering a wealth of data and images from Jupiter and its moons. In 2021, the mission was extended to focus specifically on studying these moons with the goal of understanding the processes occurring beneath their icy surfaces. This has been made possible thanks to the probe's advanced camera systems such as JunoCam and the Stellar Reference Unit navigation camera, which have captured some of the most detailed images of these moons to date. As the mission is approaching its end in September 2025, it is a fitting time to review the progress made so far and the impact these findings have had on our understanding of the Jovian system. Join us today as we take a closer look at the highlights of the extended mission and explore the many surprising discoveries that have been made thus far. In 2011, the Juno probe was launched from Cape Canaveral, Florida, and after 5 years and 28 billion kilometers of travel, it began orbiting Jupiter in July 2016. Initially completing its primary objectives, NASA extended the mission to focus on some of Jupiter's largest moons. The extended mission will include 42 orbits, or perijobes, by 2025. At the end of the mission, NASA plans to deorbit the probe by burning it in Jupiter's atmosphere to avoid any potential contamination of its moons. This is in line with NASA's planetary protection guidelines, but it's particularly important in Juno's case as scientists have been wondering if there may be life on Jupiter's inner moons. NASA wants to avoid any interference with any potential discoveries. In June 2021, Juno performed a close flyby of Ganymede using a gravity assist, which brought its orbital period down to 43 days from 53 days. In 2019, this Juno probe conducted a distant flyby of Ganymede, coming within 97,000 kilometers of the moon's surface. However, in its recent flyby in 2021, the probe was able to come much closer, coming within just 1,000 kilometers of Ganymede's surface. The photograph captured by JunoCam during this flyby shows nearly half of Ganymede's surface in incredible detail, with a resolution of about 1 kilometer per pixel. The image showcases Ganymede's unique surface features, including craters, light and dark patches, and long striations. The darker areas on the surface are older and heavily cratered, while the lighter areas are relatively younger and less cratered. These variations in color and texture can give scientists insight into the geology and history of Ganymede. The long striations seen in the image are thought to be caused by tectonic movements caused by heat from the moon's iron-nickel core. This is still the subject of ongoing research, as scientists are also interested in the subsurface ocean that lies beneath Ganymede's icy exterior, which could potentially be suitable for life. The existence of a subsurface ocean is a topic of much interest among scientists and researchers, as the presence of liquid water is one of the key requirements for the possibility of life. With the high-resolution images captured by JunoCam, scientists will be able to study Ganymede's surface in greater detail and potentially uncover more information about the subsurface ocean and the potential for life on this icy moon. This image, taken during the same flyby on June 7th, provides a more detailed view of Ganymede's Tross crater. The reason it appears so bright is because it's covered in ice. Another photograph taken on June 7th by Juno's Stellar Reference Unit navigation camera shows Ganymede's dark side. The Stellar Reference Unit camera was designed to keep Juno on course using starlight, making it particularly well suited for capturing images in low-light conditions. The resolution of this image is between 600 and 900 meters per pixel. It's worth noting the moon's long striations and craters, some of which are stacked on top of each other. The level of detail captured by Juno in these low-light conditions is impressive and unique among the many photos of Ganymede that have been taken so far. What's fascinating is that one of the most unexpected discoveries from the mission was not made by the Juno probe itself, but by the Hubble telescope. NASA used Hubble to monitor Ganymede's ultraviolet signals in order to support Juno's exploration of the Jovian moons. Ganymede has a very thin atmosphere, and one of NASA's goals was to search for traces of oxygen that were suspected to be present. It was widely expected that there would be a significant amount of oxygen based on previous analysis of the moon's ultraviolet emissions, but to everyone's surprise, Ganymede's atmosphere had very little oxygen in it. Instead, a large amount of water vapor was found. The discovery has led to a significant revision of our understanding of Ganymede's atmosphere and could suggest that water vapor might also be present in the atmospheres of other icy bodies throughout the solar system. Following its flyby of Ganymede, Juno conducted a flyby of Europa on September 29, 2022, which allowed the probe to use Europa's gravity to shorten its orbit to 38 days. One of the images captured during the flyby, taken from a distance of 351 kilometers, shows a portion of Europa just north of the equator. What is particularly striking in this image is the day-night boundary, also known as the terminator. The deep shadows in this image accentuate the ridges, troughs, and craters on Europa's surface, making it appear almost three-dimensional. Scientists theorize that Europa, like Ganymede, has a vast ocean beneath its icy exterior. However, new findings suggest that there may be more happening on Europa than just an ocean beneath a crust of ice. The photograph shown here was taken by Juno's Stellar Reference Unit camera during Europa's night, and it shows a zoomed-in portion of Europa's surface. At first glance, it may be difficult to understand what you are seeing, but the image depicts a heavily fractured region of Europa's surface, crisscrossed with grooves and ice ridges. These features are believed to be the result of tectonic activity caused by heat from the moon's iron-nickel core. Additionally, the dark patch in the center of the image could hold important clues to the geological complexity of Europa's surface. Scientists speculate that this dark patch might be an indication of a subsurface ocean, which could be more complex than previously thought. With the high-resolution images captured by JunoCam, scientists will be able to study Europa's surface in greater detail and potentially uncover more information about the subsurface ocean and the potential for life on this icy moon. Furthermore, scientists concluded that the darkened area in the image shows an eruption occurring beneath the surface ice on Europa. However, the ice on Europa is over 10 kilometers thick, which makes it hard to imagine the pressure that would be required to penetrate such a thick layer of ice. A recent paper published by the American Astronomical Society presents a new theory that offers an alternative explanation. According to the authors of the paper, the cryovolcanic activity on Europa shows evidence of brine reservoirs trapped within the icy outer crust. This would mean that there could be lakes of high salinity brine located above the moon's subsurface ocean that slush about, causing the surrounding ice to expand like a balloon and bursting through on occasion. The theory that brine reservoirs are trapped within Europa's icy outer crust is intriguing, but it may take the European Space Agency's Clipper mission, which is set to reach Europa in 2030, to confirm it. While we wait for the Clipper mission, it's worth noting that during its visits to Ganymede and Europa, the Juno probe also solved a long-standing mystery. In 1978, during the Voyager mission's visit to Jupiter, the probes detected mysterious flashes in Jupiter's atmosphere. Scientists initially assumed that these were lightning flashes similar to those seen on Earth, implying the presence of water in all its states: solid, liquid, and gas. Given what is previously known about Jupiter's atmosphere, scientists believed that these mysterious flashes detected by the Voyager mission were coming from storms that were at least 45 kilometers below the visible cloud tops. However, Juno disproved this theory with the discovery that the flashes are at a far higher altitude than previously thought possible. The Stellar Reference Unit camera on Juno saw strange nighttime flashes at this high altitude. Given the extremely cold temperatures at this altitude, which reach below -88 degrees Celsius, scientists deducted that these flashes are caused by thunderstorms made of ammonia water-based clouds, which is a phenomenon that does not exist on Earth. In these strange and violent thunderstorms, the ammonia acts as an antifreeze, forming a solution of 2 parts water and 1 part ammonia that remains liquid despite the freezing temperatures. The storms also produce powerful lightning strikes and rain down massive hail made of water ammonia slush, which scientists are calling mushballs. Indeed, Jupiter is a mysterious planet, and the more we learn about it, the more peculiar it becomes. The Juno mission has been a trailblazer, uncovering new information about Jupiter and its moons. So far, the mission has provided us with some of the best highlights of its journey. The next destination for Juno is Io, which is planned for this year. Personally, I am excited to see what new discoveries await us on Io. Juno has extended my expectations at every step of the way, and if Ganymede and Europa are any indication, our understanding of Io is about to become even more fascinating. The images that Juno has captured are sharp and awe-inspiring. Thank you so much for watching the video! Don't miss out on our latest uploads. If you wish to stay up to date with the latest space updates and discoveries, hit the subscribe button, like the video, and turn on all notifications to see more of our latest videos in the future.